Welcome to our journey through the cosmos. Prepare to be amazed as we venture into the great expanse beyond our world to explore some of the grandest, most awe-inspiring wonders of the universe galaxies. These aren't just random sprinklings of stars, but vast, swirling cities of light, each with its own story to tell. Today, we're exploring some of the most remarkable galaxies in the universe. We'll journey millions of light years away to witness the cosmic ballet of stars, gas, and dust, to understand their unique characteristics and the mind-boggling phenomena they hold. Buckle up, because we're about to take off. Our first stop takes us to a galaxy not so far away, cosmically speaking of course. It's Andromeda, our galactic next-door neighbor, a mere 2.5 million light-years away. Now that might sound like an immense distance, and it is on a human scale, but in the grand scheme of the universe it's just a stone's throw. Andromeda is a spiral galaxy, much like our own Milky Way, but it dwarfs our home galaxy in size. Picture this: while the Milky Way is home to hundreds of billions of stars, Andromeda boasts a staggering 1 trillion. It's a cosmic giant, a sprawling city of stars, gas, and dust twice the size of our own. And here's the kicker: Andromeda is on a collision course with the Milky Way. Don't worry though, this cosmic smash-up won't happen for another 4 billion years. But when it does, it will be a sight to behold. The two galaxies will slowly intertwine, their gravitational forces pulling and stretching them, creating spectacular tidal tales of stars and gas. Over eons they will merge, forming one colossal elliptical galaxy. This isn't the end though, it's a new beginning, the birth of a new galactic structure. Next we travel 23 million light-years to the constellation Canes Venatici, where we find the Whirlpool Galaxy, also known as Messier 51. Now this galaxy is a sight to behold. It's a classic spiral galaxy with majestic arms swirling outwards from a bright central core. But what makes the Whirlpool Galaxy truly remarkable is its dance partner, a smaller, nearby galaxy. This cosmic duo is locked in a gravitational waltz, their interaction creating stunning waves of star formation that ripple through the Whirlpool's arms. These waves are like cosmic ripples in a pond, triggered by the gravitational pull of the smaller galaxy. As this smaller galaxy passes by, its gravity compresses the gas and dust in the Whirlpool's arms, causing them to collapse and ignite new stars. This process creates the stunning, almost painted-like appearance of the Whirlpool Galaxy, with its bright blue star-forming regions strung along its spiral arms like celestial jewels. Our cosmic voyage now takes us 29 million light-years away to the constellation Virgo, where we find the Sombrero Galaxy, also known as Messier 104. This galaxy, my friends, is an enigma wrapped in a riddle, wearing a hat. It gets its name from its unique appearance. Imagine a giant cosmic sombrero tilted at a jaunty angle. That's the Sombrero Galaxy. It's a spiral galaxy, much like our own Milky Way, but with a twist. Literally. You see, the Sombrero Galaxy is seen edge-on from our perspective here on Earth, giving it that distinctive hat-like shape. This edge-on view allows us to see the galaxy's prominent dust lane, a thick band of dust and gas that cuts across the galaxy's equator. This dust lane is so thick that it obscures the light from the stars behind it, creating the dark brim of the cosmic sombrero. But that's not all. At the center of the Sombrero Galaxy lies a supermassive black hole, a gravitational monster billions of times the mass of our sun. This black hole is actively feeding, pulling in gas and dust from its surroundings and blasting out jets of energy that can be seen across millions of light-years. Chapter 4. Pinwheel Galaxy, a star-making factory. Our next destination lies 21 million light-years away in the constellation Ursa Major, home to the Pinwheel Galaxy, also known as Messier 101. This galaxy is a textbook example of a grand design spiral galaxy with well-defined spiral arms that extend outwards from a bright central bulge. Unlike the Whirlpool Galaxy, which has more loosely wound arms, the Pinwheel Galaxy's arms are clearly defined, almost like the spokes of a giant cosmic wheel. And they're not just pretty to look at, my friends. These spiral arms are hotbeds of star formation. The Pinwheel Galaxy is awash in gas and dust, the raw materials for new stars. As this material gets caught up in the density waves that create the spiral arms, it gets compressed, triggering the birth of new stars. The Pinwheel Galaxy is a star-making factory, churning out new suns at a furious rate. We see massive star clusters, glowing nebulae, and regions of intense star formation scattered throughout its spiral arms. Chapter 5. Messier 87, the galaxy with a supermassive secret. Now let's travel 55 million light-years away to the constellation Virgo, where we find a giant elliptical galaxy, Messier 87. Unlike the graceful spirals we've seen so far, M87 is more of a cosmic football, a giant elliptical ball of stars. But don't let its shape fool you. This galaxy harbors a monster at its heart, a supermassive black hole, one of the most massive we've ever discovered. We're talking about a black hole with a mass billions of times that of our sun, a gravitational behemoth that warps the fabric of space-time around it. And it's not just sitting there quietly. This black hole is active, feeding on gas and dust, spewing out jets of energetic particles that stretch for thousands of light-years. These jets are a testament to the immense power of the black hole, a reminder that even in the darkness there is incredible energy. Chapter 6. Large Magellanic Cloud, a satellite on a cosmic dance floor. Our next stop takes us closer to home, to a dwarf galaxy that's a mere 163,000 light-years away. This is the Large Magellanic Cloud, a satellite galaxy of our own Milky Way. Now you might think of a satellite as something artificial, orbiting our planet. But in astronomy, a satellite galaxy is a smaller galaxy that's gravitationally bound to a larger one. The Large Magellanic Cloud is engaged in a cosmic dance with the Milky Way, their gravitational interaction creating a stream of gas and dust that stretches for thousands of light-years. This stream, known as the Magellanic Stream, is evidence of the ongoing interaction between these two galaxies. The Large Magellanic Cloud is also a hotbed of star formation. It's home to the Tarantula Nebula, the most active star-forming region in our galactic neighborhood. This nebula is a vast cloud of gas and dust illuminated by the intense radiation of newborn stars, a cosmic nursery where stars are born. Chapter 7. Triangulum Galaxy, the third wheel in our local group. Now let's hop over to the constellation Triangulum, about 3 million light-years away. Here, we find the Triangulum Galaxy, also known as Messier 33. This spiral galaxy is the third largest member of our local group, a collection of over 50 galaxies that includes the Milky Way and Andromeda. But don't let its ranking fool you. The Triangulum Galaxy is a fascinating place, a swirling disk of stars, gas, and dust with its own unique characteristics. It's less massive than both the Milky Way and Andromeda, but it's still a sight to behold. One of the most striking features of the Triangulum Galaxy is its open spiral structure. Unlike the tightly wound arms of some spiral galaxies, the Triangulum Galaxy's arms are more loosely wound, giving it a more delicate, almost feathery appearance. This open structure is thought to be due to the galaxy's relatively low mass, which means that its spiral arms are less tightly bound by gravity. Our cosmic journey takes us 12 million light-years away to the constellation Centaurus, where we find Centaurus A, also known as NGC 5128. This galaxy is a peculiar one, a cosmic train wreck frozen in time. You see, Centaurus A is what's known as a peculiar galaxy. It's a galaxy that's been distorted by a past interaction with another galaxy. In the case of Centaurus A, this interaction was a doozy. Astronomers believe that Centaurus A collided with a smaller spiral galaxy billions of years ago. This collision ripped apart the smaller galaxy, scattering its stars and gas across hundreds of thousands of light-years. The remnants of this cosmic collision are still visible today in the form of warped dust lanes, shells of stars, and a supermassive black hole at the center of the galaxy that's feasting on the debris. Let's hop over to the constellation Draco, about 420 million light-years away, where we find the Tadpole galaxy. This galaxy earns its name from its unusual shape. It looks just like a cosmic tadpole, with a bright head and a long, trailing tail. But this isn't just a case of pareidolia, my friends. This galaxy's unique shape is the result of a dramatic cosmic event. Billions of years ago, a smaller galaxy passed right through the Tadpole galaxy, like a bullet through a cloud of smoke. This close encounter didn't destroy either galaxy. Instead, it created the tadpole's distinctive tail. The gravitational forces of the passing galaxy drew out a long stream of stars and gas from the Tadpole galaxy, creating the tail we see today. It's a reminder that even in the vastness of space, galaxies aren't isolated islands. They're constantly interacting, colliding, and shaping each other through the force of gravity. Our final stop takes us 500 million light-years away to the constellation Sculptor, where we find the Cartwheel Galaxy. This galaxy is a prime example of how cosmic collisions can create objects of breathtaking beauty. Just like the Tadpole Galaxy, the Cartwheel Galaxy gets its name from its unique appearance. It looks like a giant cosmic cartwheel, with a bright central ring and spokes radiating outwards. But this wasn't always the case. Billions of years ago, the Cartwheel Galaxy was a normal spiral galaxy, much like our own Milky Way. But then, a smaller galaxy plowed right through its center, creating shockwaves that rippled outwards, like ripples in a pond. These shockwaves triggered the formation of new stars in the Cartwheel Galaxy's outer regions, creating the bright ring we see today. The spokes are streams of stars and gas that were drawn outwards by the collision, creating a cosmic pinwheel that's still spinning today. Thanks for joining us on this cosmic journey. We've only scratched the surface of the amazing diversity and wonder of galaxies in our universe. From the spiral arms of the Whirlpool Galaxy to the supermassive black hole at the heart of Messier 87, we've seen that the universe is full of surprises. Don't forget to like, subscribe, and hit the bell icon for more amazing space content. See you next time, space explorers.